Welcome to Northern's Craft. Today we are going to study Lagrange's Mean Value Theorem, or simply Mean Value Theorem. So actually what it is, it says if there is a function fx, which follows, it is continuous in closed interval a comma b and differentiable in open interval a comma b. Then it says there is a point C between A and B. Between A and B, there's a point C which lies, and differentiation of f function with respect to C will be equal to average of fb minus fa divided by b minus a. As you can see over here, one graph as well, how it is made. So this is the definition of mean value theorem. It says if there is a function fx which is continuous in a closed interval ab and differentiable in open interval ab, then there exists point C whose differentiation is equal to fb minus fa or divided by b minus a. Now let's move forward. Let us solve one problem by which we will understand Lagrange's mean value theorem in a proper way. So here's a question. It's given as fx is equal to sin x on pi t. Now we need to find the value of c. Considering this is continuous in open interval AB and closed interval AB, differentiable in closed interval AB, open interval AB, and continuous in closed interval AB. Now we will find C. Now see, first step is we find f dash c is equal to sin, accordance with our formula. We are going in accordance with our formula. This will be just need to write the formula right now. First fb minus fa all divided by b minus a. Now the second step is just put the value in the function. After putting the value, it's sin x, sin pi is b minus sin 0 all divided by b minus a, pi minus 0. So it comes to be, as we know, sin pi means sin 180 is 0 and sin 0 is also 0, divided by 0 by pi is equal to 0. F dash c is equal to 0. Now, but our objective is to find c. Now third step. The third step is, we know that fc is equal to sin c. F dash c will be equal to cos c. Differentiation of sin x, sin c is equal to cos c. Now equating this equation with a value that we get, f dash c, which is equal to 0, implies c is equal to cos inverse 0, which is pi by 2. So this is the mean value theorem. Now we will understand the derivative test. There's two derivative tests. First derivative test and second derivative test. If test. So actually what happens is, if, as we know, if we differentiate the function fx, which is said to be continuous in a closed interval ab and differentiable in open interval ab, then if its value come positive, we say graph will be upward direction. If its value come negative, then we say graph will be in downward direction, upward direction, downward direction. And if the value is 0, if this value is 0, now we are talking about the first derivative. If its value is equal to 0, then the graph will be the horizontal graph. Now let's talk about the second derivative test. So second derivative test says, if we double differentiate the same function and it's positive, still positive, then it implies graph is upward plus curve concave. And if it's negative, then it's downward and concave. And now, if in this case, if these two cases are, this first derivative test and second derivative test are done, now if the value of the function, if comes 0, then its graph will be linear. Linear will be its graph. Now we will again take the same example that we have taken earlier. Fx, we have considered sin x on 0 to pi. As we have differentiate x and we got cos x, and we see the value of the graph in this case, when we put the value c, f dash c, cos c, and c is our pi by 2, the value comes 0, it means graph is linear. This is the first derivative test. Now second derivative test will do. If we double differentiate the cos x, then we get minus sin x, and we know value of c is pi by 2, and again we get 0. F double dash c is 0, which implies graph is linear. Therefore, this is the mean value theorem, or we can say Lagrange's mean value theorem. Lagrange is the scientist who have a big contribution in finding this mean value theorem. Now, further we examine our theory. There is a special case of mean value theorem which is called Rolle's theorem. Rolle's theorem. In mean value theorem, we see if therefore a type of function exists, then we say its average axis. But in case of Rolle's theorem, we say this is axis and it's equal to 0. which implies its slope is 0. This is the case in the Rolle's theorem, applying the all condition of Lagrange's mean value theorem. So this is Rolle theorem, and it's a special case of Lagrange's mean value theorem. Thank you for watching my video. Please like and subscribe my video. It will help to grow my channel. Thank you very much.